So in this flipped classroom lesson, I want to talk about refraction. And I'm starting off with a piece of ordinary glass. It's a big, thick piece of glass right here. And I'm going to shine a laser through it. So here's my laser light coming through. And you can see that it does as you would expect. It goes through in a perfectly straight line. That's what light should do when it goes through glass, right? It should just go going in a straight line. So if you look out a window, then the light continues in a straight line. However, if I shoot the light from an angle, then it's going to do something a bit strange. There's a lot going on here, so let's break it down. First, you can see that there is a reflection right about here, and that's an equal angle, just like we learned. But then something odd is happening. Some of the light is reflecting, but the light that goes into the glass is changing direction, and it changes direction right here at the glass-air interface. And then it changes direction again coming out over here. And you can probably see there's another little reflection here. But this changing direction, when it goes from air to glass, and then from glass to air, well, that is something we have not seen before. And that is called refraction. It's not reflection, it's refraction, which is a different word. And it's when light bends when it goes from one medium to another. Let's take a more in-depth look at this phenomena of refraction. I'm going to shoot a laser light from right here, angle it in at various different angles. And we're going to see where the light goes when it enters the glass. I'm going to start right down this line which runs perpendicular to the glass. It's dotted. This is also known as the normal line. And it does exactly what you expect. It goes straight through. But if I come in at a little bit of an angle, then you might be able to see that it's bending just a slight little bit. If I come in at a steeper angle, it's going to bend even more. And if I come in at a really steep angle, it's going to bend quite a bit. And it's going to bend approximately down that red line, which just happens to be drawn right there. And that is the maximum it's ever going to bend. So what we can see is that if the light comes, where I wrote incident light, anywhere on this angle, that it gets shot somewhere in here, and it reaches a maximum. It never bends, it never goes over here. No light here. Now, I bet there's some kind of relationship between some property of the glass and the angle of incidence and the angle of refraction. And I think that would make for a really good lab to investigate how the angle of incidence relates to the angle of refraction. So let's give it a whirl. We can do this lab in a really similar way that we did the reflection lab. I've brought out the angle paper again. Here's 0 degrees right along the normal line. If I shoot my laser through, you can see it comes out at about 0 degrees. So instead of measuring a reflection, we're measuring angles over here now. And if I shoot it in at, say, 20 degrees, we can then measure where it's going, where light comes over here, whatever that angle happens to be. Piece of cake, right? There's only one little issue. See this big, ginormous glass block? I only have the one, because we don't, in fact, have counters filled with gigantic glass blocks, but what I do have are little glass blocks like this. It's frosted on the bottom side here, so if I line it up here and I shoot the laser in, it's going to refract. Unfortunately, it's going to refract again when it comes out, and you can't read any angles here. So what are we going to do? So how can we measure the angle of incidence and angle of refraction? We can use a semicircle. Now this is a semicircular piece of glass, and the beauty of a semicircle is that if I shine the light right at the center of this semicircle, the light is going to change direction. It's going to refract when it enters, and then when it comes out, it's coming out straight. It's hitting this at a right angle, right along the normal, so it just comes straight out. So we can measure the angle way over here. So as long as we have a semicircle and we hit it in the center of the semicircle right there, the angle it comes out is going to be perfect. It's not going to change when it goes from glass to air over here. So in order to set up this lab, we first have to line this up very precisely, not only on the line here, but also exactly centered here. And then we can shine our laser at various different angles. So I shine it at 30 degrees, and it comes through, and I can then measure where that light comes out over there on this side. And we can also use these handy little cups. They're semicircular cups. You can fill them up with any liquid like water or, say, simple syrup or oil, and you can measure how light bends when it enters these things. And you can do the same exact thing. Just put it right here. And that's going to be our lab. Good luck. One final note about this lab, measuring the angles. If you line up this surface at right angles with 0, then you can measure 10, 20, 30, 40, etc., those degrees. And that's pretty easy for measuring the angle of incidence. But then what do you do about the angle of refraction? Because if I shoot it here at 30 degrees and it comes out, it's going to come out around, 200 or 160 degrees? Wait a second, that doesn't make much sense. This is perpendicular to the surface, so this is 0 degrees. Go over 10, and this is actually 20 degrees. I don't care what the numbers say, it's 20 degrees because this is 0 degrees. Okay, hope that clarifies it.